inverse Z transform by power series expansion method. In this, we expand x of z into a power series of the form x of z equals to, within the limit minus infinity to infinity, cn z to the power minus n. Okay, which this series converges for a given region of convergences, ROC, that is. Okay, here x of n is equal to cn. Three cases arises when ROC is greater than some radius r, or ROC is less than some radius r, or ROC is between radius r1 and r2. First case means it is a causal signal and ROC is exterior of the circle. This is circle is of radius r. Okay. Second case is non-causal signal and ROC is interior of the circle of radius r. Third case is also a non-causal signal and ROC is between the radius r1 and r2. Okay, that is ring form. If causal signal means sequences right hand side. For non-causal signal, this case sequences left hand side. Okay, and in third case, the sequence is two-sided sequence. One thing we should remember, that if x of n exists for n less than 0, it means a signal is non-causal. Okay, now let's start with example. If x of z is rational function, that is, it is described by polynomials, numerator polynomials divided by denominator polynomials. Okay, then expansion is performed by long division method. Okay, let's start with the example. First example, we have to find inverse z transform x of z, which is a rational function 1 plus z to the power minus 1 divided by 1 minus 1 by 3 z to the power minus 1. Okay, for a given ROC, when first case, when ROC is greater than 1 by 3, that means it is a causal signal and ROC is exterior of the circle. The radius of the circle is 1 by 3. And in second case, ROC is equal to z to the power, z is less than 1 by 3. That is interior of the circle. Circle radius is 1 by 3. Okay. First we see first case, ROC is greater than 1 by 3. Okay, for causal signal. Second case, non-causal signal. Okay, we know that for causal signal, the power of z obtained is like this: x of 0 plus x of 1, z to the power minus 1, x of 2, z to the power minus 2, and so on. X of n, z to the power minus n. Okay, means for causal signal, the power of z is negative. Similarly, for non-causal signal, the power of z is positive. Okay, so for long division method, we must take care of that the result should be, for causal signal, it should be a power of negative power. Z's power should be negative. Okay, now let's start. X of z is given is 1 plus z to the power minus 1 upon 1 minus 1 by 3 z to the power minus 1. By using long division method, okay, 1 plus z minus 1 is divided by 1 minus 1 by 3 z to the power minus 1. Okay, in order to cancel this 1, we multiply this denominator by 1. The result we get is 1 minus 1 by 3 z to the power minus 1. Now to cancel this, change the sign. So 1 minus 1 is 0. Result we get is 4 by 3 z to the power minus 1. Why? Z to the power minus 1 plus this will become positive sign. So plus 1 by 3 z to the power minus 1. The result we get is 4 by 3 z to the power minus 1. Okay. Rough work. Next, in order to cancel this 4 by 3 z to the power minus 1, we multiply 4 by 3 z to the power minus 1 by denominator. So we get the result 4 by 3 z to the power minus 1 minus 4 upon 3 3s are 9 z to the power minus 2. Now, in order to cancel 4 by 3 z to the power minus 1, change the sign. So 4 by 3 z to the power minus 1 and minus 4 by 3 z to the power minus 1, we get the result 0. And the remainder is 4 by 9 z to the power minus 2. Next, in order to cancel 4 by 9 z to the power minus 2, we multiply 4 by 9 z to the power minus 2 with the denominator. We get result 4 by 9 z to the power minus 2 minus 4 by 27 z to the power minus 3. Okay. Now change the sign of this whole expression. We get result 4 by 27 z to the power minus 3. Next, what we should multiply? We should multiply 4 by 27 z to the power minus 3. And so on, this will go on. Okay. So the result of this division is equals to 1 plus 4 by 3 z to the power minus 1 plus 4 by 9 z to the power minus 2 plus 4 by 27 z to the power minus 3 and so on. Okay. Now take the inverse. We say this equation is 1. Now take the inverse of this equation 1. We get x of n is equal to sequence 1 when n is equal to 0. Then 4 by 3, 4 by 9, 4 by 27 and so on. Okay, this is the result. And this is a causal sequence. Right hand side sequence 1 and so on. Okay. Next case, when signal is non-causal, that is ROC given is x of z here is 1 plus z to the power minus 1, 1 minus 1 by 3 z to the power minus 1. Okay. When ROC given is z is less than 1 by 3, that is non-causal sequence. Okay. This is a non-causal signal. So, why? Because the ROC is interior of the circle. Okay. So, we will get the power of z positive. Okay. Now, let's start. How we will get? Just rearrange the numerator and denominator before long division method. Okay. Numerator we write like this, z to the power minus 1 plus 1. And denominator here we will write 1 by 3 z to the power minus 1 plus 1. Okay. Now let's start long division method. In order to cancel z to the power minus 1, we should multiply minus 3 to the denominator. That is minus 1 by 3 z to the power minus 1 and plus 1. Okay. So the result we get is z to the power minus 1 minus 3. Now change the sign in order to cancel z to the power minus 1. We get the result 4. Now in order to cancel this 4, we should multiply the denominator by minus 12z. So we get the result 4 minus 12z. Okay. Now change the sign. We will get result 12z. Next we will multiply 36 z to the power 2 with the denominator, and the result we get is 12z minus 36z square. Okay, change the sign. The remainder we get is 36z square, and so on. This will continue. Okay, so the result of this long division is x of z is minus 3 minus 12z minus 36z square and so on. Okay. Now this is we call equation 2. Now take the inverse of this equation 2. We get result x of n is equal to minus 3 initially when n is equal to 0, and then when n is equal to minus 1 it is 12, then for minus 2 it is 36, and so on up to minus infinity. Okay, this is a left hand side equation sequence. Okay, this non-causal signal. Okay, now in this long division method, closed form solution is not possible. Method is used to determine the value of the first few samples of the signal. Okay, now let's take next example. Example 2. We have to find the inverse Z transform of log of 1 plus a z to the power minus 1. And ROC given is z is greater than a. From this ROC, we must come to the conclusion that it is a causal signal, exterior of the circus is ROC. We have to find this inverse Z transform using power series expansion method. Okay, this is the question. Now let's solve this. We know log of 1 plus x is equal to summation of n equal to 1 to infinity minus 1 by n minus x to the power n. Okay, when we open this or expand this series, we get x minus x square by 2 plus x cube by 3 minus x4 by 4 and so on. This is the power series of log of 1 plus x. Okay, therefore x of z equals to log of 1 plus a z inverse will be a, since x is here is a z to the power minus 1, the substitute in this equation, let's say equation 3. Okay, a to the power z to the power minus 1 minus a z to the power minus 1 whole square by 2 plus a z to the power minus 1 cube by 3 minus a z to the power minus 1 to the power 4 upon 4 and so on. Okay, in compact form we can write as, we use this, we can write this as n equals to 1 to infinity minus 1 upon n minus a z to the power minus 1 upon n. Just rearrange the terms again. N equals to 1 to infinity minus 1 by n. Here we separate minus n z to the power minus n. Okay, equals to n equals to 1 to infinity minus 1, again rearranging minus 1 n upon n, and a we taken out from this, a to the power n z to the power minus n. Okay, so n equals to 1 to infinity minus 1 upon n plus to the power n plus 1 upon n a to the power n z to the power minus n. We know Z transform formula is n equals to minus infinity to infinity x of n z to the power minus n, means this is the x of n. Okay, so inverse Z transform is equal of this log of 1 plus a z to the power minus 1 is minus 1 to the power n plus 1 upon n a to the power n. As the limit here is n start with 1, so it is a shifted version, and u of n minus 1, as this is a causal signal given, ROC is given as z is greater than a. That's why u of n minus 1. Okay, this is the result. Now let's take another example. Example 3. X of z here is given as e to the power z. ROC is entire z plane except z equals to infinity. Okay, now the power series e to the power x is equal to, we know that n equals to 0 to infinity x of x to the power n factorial n. Again we can write it instead of x, we just replace z, so that we get e to the power z is equal to n equals to minus infinity to first n equals to 0 to infinity equals to z to the power n upon n factorial. Okay, as we know that our formula is x of z is equal to minus infinity to infinity x of n z to the power minus n, that is negative sign, but here we get here is positive sign, so just change the sign, so the limit also will get changed. Here n is minus infinity to 0 and z to the power minus n upon factorial minus n. Okay, again just rearrange the terms. N equals to minus infinity to 0, 1 upon minus n factorial. Okay, and u of minus n z to the power minus n. Okay, now this is x of n. Okay, by comparing this equation, let's say equation 4, by we compare equation 4, we get x of n equals to minus n factorial u of minus n. Okay, folded version of un. Now let's take another example. Example 4, x of z is sine z, sine of z. Okay, and we have to find out the inverse z transform of this sequence. We know that sine x is equal to x minus x to the power 3 factorial 3 plus x to the power 5 factorial 5 minus x to the power 7 factorial 7 and so on. Just this equation, we can say equation 5. In equation 5, instead of x, replace this by z. Okay, so x of z equals to sine of z is equal to z minus z to the power 3 factorial 3 plus z to the power 5 factorial 5 minus z to the power 7 by factorial 7 and so on. Okay, this is the series. Therefore, if you take the inverse z transform of this equation number 6, we get x of n equals to, since it is z to the power 0 is no element, coefficient is 0, so initially it is 0, and at n equals to 0, its coefficient sequence is 0, then z to the power 1, so its coefficient is 1, then z to the power minus 2 is missing, so its coefficient is also 0, then 1 by 3 factorial, then again as z to the power 4 is missing, so its value is 0, then 1 factorial 5, again z to the power 6 is missing, so its value is 0, and then 1 factorial 1 by 7 factorial 7. Okay, and so on. It means our this sequence is non-causal, left-handed sided sequence. Its value is 0 at n equals to 0 and 1 when n is equal to minus 1. Okay, and 0 when n equals to minus 2. Again, its value is factorial 1 by 1 upon factorial 3 and so on. Okay, so it is a left-hand side sequence, that is non-causal sequence. So ROC is interior of the circle. Okay. In next session, we will take the examples of partial fraction expansion method. We will see it. Okay. Thanks.